Good morning. I'm John Innsbrucker, and when I'm not doing the webcast, I'm the Falcon 9 Product Director. Falcon 9 is currently counting down just over 42 minutes from now for a launch at 9 a.m. Pacific Daylight Time, or 1600 hours Universal Time, launching from Slick 4 East in Vandenberg Air Force Base, California. Now that pad brings back memories for me. It was over 30 years ago as a young Air Force officer where I worked on the very same launch pad we're using today, where I was launching Titan 3D vehicles into space. Then I also came back on the Titan 4 program, where we also launched about a decade ago from the same pad. Since then I've joined SpaceX, and in the last couple of years we've taken that pad and renovated it to where it's now the site for Falcon 9s and future Falcon Heavy launches into polar orbit from the Western Range in California. Now right now around us here in Hawthorne, the building is filling with folks. You can feel the energy start to rise as we're following the Falcon 9 team as it counts down for launch this morning. Now, as I've done on the last several flights, I'll bring status updates throughout the countdown. So let's take a look at the vehicle, the spacecraft, the range, and the weather right now. Falcon 9 launch vehicle, as you can see there on the webcast, the SpaceX team is working no issues on the booster. We began loading propellant, liquid oxygen, and kerosene fuel over 3 hours ago. We currently have over 1 million pounds of propellant on the first and second stages. We're currently continuing to top off the liquid oxygen in the first and second stages, and you can see that with the white plume coming off of the vehicle occasionally. We'll continue that up until the last minutes before liftoff. We're also loading high-pressure helium into storage bottles on the first and second stages, and we'll continue topping that off also until the last minutes. On the electrical side, we've done our vehicle tests, and we're currently on external power. We'll switch to internal batteries as we get inside of the terminal count. The payload for today is the CASSIOPE spacecraft for the MDA Corporation of Canada. CASSIOPE is an acronym. It stands for the Cascade SmallSat and IOnospheric Polar Experiments. The Cascade SmallSat is a communication payload dedicated to high store and forward data rate communications. It also hosts several experiments. That makes up the Ionospheric Polar Experiments part of the name Cassiope. The spacecraft right now has recently completed, just several minutes ago, topping off its batteries, so the spacecraft is go for launch. There are no significant activities remaining on the spacecraft between now and T0. We're launching out of the range at Vandenberg, the Western Range. They provide support to SpaceX for this upcoming launch. They're giving us the radar, the optics, they're doing the weather support and the flight safety, as well as telemetry reception. So as the Falcon 9 flies downrange, the data we're getting back is passing through the Western Range at Vandenberg. Currently, the range reports to the team that they're working no issues, their staff, their equipment is up and running, and they're ready to support today's launch. The last factor that everybody's looking at is the weather, and as you can see on the webcast, it's a beautiful day at Vandenberg. We managed to get blue skies and no fog. The ground weather conditions are excellent. The weather officer has reported an amazing 0% probability of violating conditions for the 9 a.m. liftoff. Now we are also releasing balloons. We've been looking at that data, and currently we are within allowables to fly the Falcon 9 into space. So the booster, the spacecraft, the range, and the weather all cooperating. We're at T-minus 38.5 minutes, counting down for launch this morning.
Today's launch window opens at 9 a.m. Pacific, 12 p.m. Eastern, and will run for 3 hours. And what that means is we can launch at any time in that 3-hour window. So as John said, we're going to be checking in on status, and if for some reason the upper atmospheric winds change or something changes, we might go a little bit later in our window today. Or there's a chance that we might wind up scrubbing today. If that does happen, we have another backup day tomorrow. Our launch window opens at 10 a.m. Pacific time tomorrow and is going to run for 2 hours. Now, another thing that's unique to the Falcon 9 launch vehicle is that right at T0, just before liftoff, we light the engines to full thrust, and we hold it there for a second before we release the rocket. And the reason we do that is we want to ensure that A, we have full thrust, and B, that all the parameters are within specification. So this is a test that we do to make sure everything is good before launch. Now, If something is out of spec, what's going to happen is the engines will safely shut themselves down, and we'll have all the engineers looking at the data. Once they look at all the data, we can see if maybe we'll go later in the window, we can recycle and possibly go again today, or we may have to scrub for the day and come and try again tomorrow. But because we do have a lot of upgrades on the rocket and the engines, there is a chance that could happen at T0, so just to let you all know. Now, along with that, another thing that SpaceX is always trying to do is we're always trying to push the boundaries. Because we're a relatively new company with regards to aerospace, we try and look at things from a new perspective, and just instead of simply doing what's been done in the past. So we look at lighter weight materials, innovative sensor designs, try and run more complex tests. All of this to try and make basically space travel, we want to revolutionize the space industry here at SpaceX. We're really trying to do that. But with regards to that, let's go get and find out a little bit more about some of our Falcon 9 upgrades.
At SpaceX, we design, manufacture, and launch some of the world's most advanced rockets and spacecraft, including the Falcon 9. Falcon 9 is actually the first rocket to be fully designed and built in the 21st century. We've designed Falcon 9 to the highest standard of reliability possible.
And launch.
We've had 5 successful back-to-back flights, and if you combine that with Dragon, we're the only launch services provider in the world to be able to take significant amounts of cargo to and from the International Space Station. We design and manufacture Falcon 9 right here at SpaceX headquarters in Hawthorne, California. At SpaceX, we're always striving to push the boundaries of what's possible. We've continued to make upgrades to Falcon 9 to improve the performance, manufacturability, and get us closer to our ultimate goal of a fully and rapidly reusable rocket. One of the most significant upgrades we've made is to the 9 Merlin engines that power Falcon 9 to orbit. Merlin 1D, the latest iteration in the Merlin engine family, was designed to allow Falcon 9 to be reused. The engine can be throttled and restarted multiple times with a rapid turnaround time between uses. With 9 Merlin 1Ds on the first stage, Falcon 9 will produce 1.5 million pounds of thrust in a vacuum. That's greater than 5 747 airplanes at full power. With this improved design, Merlin 1D will become the most efficient booster engine ever built, while still maintaining the structural and thermal safety margins required to safely carry astronauts to orbit. Today's mission is also the first time we're flying a payload fairing instead of the Dragon spacecraft on top of our Falcon 9. The payload fairing, used on both Falcon Heavy and Falcon 9, is a composite structure that's manufactured in-house here at Hawthorne headquarters. It's used to protect the satellite before it's been delivered to low Earth orbit, geosynchronous transfer orbit, or places far beyond. The payload fairing is 43 feet long and 17 feet wide. That's big enough to fit an entire city school bus inside. Now, depending on the status of the video feed today, we may see fairing separation right before Falcon 9 delivers CASSIOPE to its intended orbit. In addition to upgrading the engines, we've also upgraded the structure that supports the 9 Merlin 1D engines at the bottom of the Falcon 9 first stage. Known as the Octaweb, this structure improves upon the former 3x3 engine configuration. The Octaweb is a metal structure that supports 8 engines surrounded by a center engine at the base of the launch vehicle. This structure simplifies the design and assembly of the engine section, greatly streamlining SpaceX's manufacturing process. Now, both the Octaweb and the Merlin 1D will see flight for the first time on today's demonstration mission. We hope you enjoyed your sneak peek into the factory today and hearing about all the upgrades that we're going to fly in today's demonstration mission. Now let's go launch that rocket.
So as you can see, we have a lot of upgrades on the Falcon 9 rocket. And all of that is wonderful, but a big part of the engineering process is you have to test all of these changes. And at SpaceX, we try and test everything we possibly can, and we also believe very strongly in testing as close as we can to how we will fly. So we want to do the best job to replicate what's going to happen in flight on the ground. And one of the ways we do that is not only do we fire every single flight engine in Texas before it gets installed on the vehicle, but we literally take all 9 engines, put them on the first stage with the flight electronics, flight plumbing, everything, and we fire the whole thing on a big test stand in Texas before flight. This is something that I don't know if any other company does this, and we also do it with our second stage. It's a really important thing for reducing the risk of failure during a launch. Now, while all that's great, we do everything we can on the ground, there are just certain events that you can't always replicate on the ground, certain flight events. So Eventually you have to move on to flight. So today we have our upgraded rocket, and one of the most important things of a demonstration mission is to have an extensive amount of instrumentation. So on today's launch, we have tons of load sensors. We'll be looking at thermal environments, vibration environments, pressures, current draw, battery power, all kinds of things. And we get all this data as live telemetry. And so what's happening is the antennas are sending this data back down to our ground stations where we get it live. This is great because if anything happens, we'll have live data to see what happened and make sure we can fix it before the next mission. Or if everything goes exactly as planned, we have a totally normal mission, then we basically verify our design, which is also a critical part. We want to be able to verify everything before the next mission. So instrumentation is a huge part of a demonstration mission, and we have tons of it. Now, another distinction for today's mission is we are launching a satellite into orbit instead of Dragon. On our previous Falcon 9 launches, we were launching a Dragon spacecraft to the International Space Station where we resupplied it with cargo. So today we have a fairing instead, and that composite fairing is manufactured here. And what it does is the nose cone fairing is what protects the satellite during launch. Keeps it in a nice thermally controlled environment. We try and keep the acoustics low. But as with any rocket, you want to get rid of mass as quickly as possible. So for example, on the first stage, when the first stage burns out, we jettison it. Now same thing with the fairing. As soon as we can get rid of it, we do. So about 3.5 minutes into flight, just after the second stage ignites, we are actually out of the atmosphere and into space at this point in time. At that point, we're going to pressurize the two halves, and the fairing will fall apart and re-enter back into the atmosphere. And that way we can get rid of that mass, which is great. And the spacecraft is on its way to orbit. Some other fun facts about the fairing are it's big. It is almost 50 feet tall, 17 feet in diameter. And it's not easy to find a place where you can test this type of structure. And so we found the NASA Plumbrook facility has the world's largest acoustic chamber, and they have one of the world's largest thermal vacuum chambers. So this is where we ran acoustic testing and our fairing separation test to ensure that it worked before flight. And so we've done all that testing so far. All of this is critical to making sure a vehicle is qualified before flight. That's something that we always have to do. And on that note, what we're going to do is turn you over to John, where he's going to talk about more safety and testing for this vehicle.
Jessica mentioned payload fairing testing. SpaceX uses high-pressure helium gas, a pneumatic system, to separate the payload fairing, as well as to separate the first and second stages of the Falcon 9 rocket. This is different than other launch vehicle providers, many of whom use explosive systems, detonating cords, explosive bolts, to hold the stages together or hold the fairing halves together and then separate them in space. However, history has shown that separating stages, separating payload fairings is one of the riskier things that you can do in a flight. Now to that end, when you're using explosives, you don't get a chance to test them until the moment of truth when you're actually out in the vacuum of space and it's got to work, but you don't know until you do it whether it's going to or not. Now at SpaceX, we look at it from a reliability and safety standpoint where we use a high-pressure gas system. That allows us to build the system, the mechanical locking joints, the pushers that push apart the first and second stages apart. We can build those, test them here in the factory, make sure they don't leak, install them onto the vehicle, test them again at the launch site, make sure everything's good, so that what we've actually done is test what we're going to fly, and that gives us the confidence from overall vehicle reliability that those systems should work when we call upon them in the flight. Now we're currently 28.5 minutes away from liftoff. Give you a little bit more on what the status is for the launch coming up this morning. Falcon 9 launch vehicle continues in liquid oxygen topping. We'll continue that up until the last minutes before launch, as I mentioned before. Now, one of the things that's coming up is at T-minus 13 minutes, we're going to do a readiness poll, and we'll let you listen into that as we then move from that into terminal countdown. Now, this morning, the launch window we have is 3 hours long. That's a little bit different than our recent flights to the space station, where we essentially had a 1-second window. So if anything held us up during the day, we wouldn't be able to launch again that same day. We'd try a different day. Today, with the 3-hour window, if we have a problem, we may have the opportunity to recycle the countdown, typically back to T-minus 13 minutes, wait for the team to understand what the problem is, fix it, and then give us another attempt. That's similar if you were with us on the early Falcon 9 flights a few years ago. So the booster's looking good right now. Cassiope spacecraft is looking good. The range continues to be ready to support with all of the systems that we need for safety and to verify the vehicle's data coming back to Earth as we fly out into out of the atmosphere and into space. Finally, balloon data shows that we're good for a launch at 9 a.m. We're waiting for some more balloon data coming here in the next several minutes to tell us if the weather is still good at the upper altitudes. But for the moment, everything's looking good for an on-time launch in just under 27 minutes.
As the world's fastest growing launch provider, it was critical that SpaceX add additional launch pads to support our ever-growing manifest. Vandenberg is the latest addition to that launch pad family. Now, it boasts a long history of military launches, and it'll also be the first place that we launch the Falcon Heavy vehicle from. Now, in order to give you a better idea and sense of what it takes to actually build and operate a launch pad, we asked Lee Rosen, our site director, to give her a tour of the facilities.
Hi, I'm Lee Rosen. Welcome to SpaceX Vandenberg. We're really proud to open up a new launch capability here at Vandenberg Air Force Base. Of course, we have Cape Canaveral where we launch into equatorial orbits, and here at Vandenberg we launch to the south over the poles, so things like weather satellites, national security satellites, and scientific satellites that look back at the Earth. Well, you can see here that Space Launch Complex 4 at Vandenberg Air Force Base has a really rich history that started in the early 60s. We really can't wait to write the next chapter and put our own sticker on the wall. We're going to be launching both Falcon 9 version 1.1 as well as the Falcon Heavy. And we're bringing a brand new capability here to Vandenberg Air Force Base, and we couldn't be more excited about it. Well, we're inside the hangar here, and you can see our great Falcon 9 version 1.1 sitting on top of our transporter erector. The transporter is 225 feet long and weighs nearly 750,000 pounds. Here we are at the forward end of the vehicle, and you can see our 43.5-foot long composite payload fairing. Inside that fairing is the CASSIOPE satellite from McDonnell Detweiler and Associates. The payload fairing protects those payloads as we ascend through the thick part of the atmosphere, and then at just the right time, we command a system to open it up and expose those satellites, ready to deploy them into space. Before launch, we'll open up this 52-foot door, roll out the rocket and the transporter erector, and make the short trip up this 850-foot road to the launch pad to get ready for launch. You do not want to be here in the flame bucket during day of launch. We use water to dampen the acoustic vibration that these engines put out. Thanks for taking the time to visit us here at SpaceX Vandenberg. Over the course of the last 2.5 years, we've really transformed this site into the world's greatest launch pad.
It's a pretty awesome pad out at Vandenberg. It's actually a pretty impressive facility here in Hawthorne too. This is where we manufacture the light and high performance composite and metallic parts that make up the Falcon 9 and the Falcon Heavy rocket. Speaking of Falcon Heavy, it's going to have 53 metric tons capability to low Earth orbit. I mean, that's going to be really impressive. I'm seriously looking forward to seeing a Falcon Heavy launch out of Vandenberg coming up really soon now.
A facility you don't see that often is our rocket development facility in McGregor, Texas. This is where we do a lot of our major structural testing, where we fire all of our engines, we fire our first and second stages, and the coolest part, this is where we've been testing our Grasshopper vertical takeoff and vertical landing vehicle. If you haven't seen the YouTube videos yet, you should definitely check them out. It's a pretty cool thing. Some people think it's kind of science fiction. Is it real? It's awesome. You should definitely check it out. Now, what the Grasshopper is, it is a full Falcon 9 first stage. It has a single Merlin engine and landing legs, and it takes off and lands entirely under its own rocket power. Now, the goal of this test vehicle is to learn how to safely return first stages back to the launch site. Most expendable launch vehicles right now, what they do is when the first stage burns out, it falls back to Earth, falls back into the ocean. Now, The shuttle, what they would do is they would go in and recover their boosters out of the ocean. It's a very expensive process to first get it out of the ocean and then B, to refurbish it. You've got all that saltwater corrosion, so it's a really expensive process to pull it back out of the ocean. You can save a lot of time and money if you could fly the first stage back to the launch site, and that is definitely one of SpaceX's goals. We want to make rockets completely reusable here. We believe that's going to be, this is what's going to revolutionize the space industry. This is what's going to drastically reduce the cost of access to space. Maybe even to the point where you or I will be able to go for a reasonable cost, which would be awesome. Now, the next set of tests we're going to do for Grasshopper, we're doing a series of increasing altitude tests and some more aggressive steering with McGregor. We are also going to be running some tests at Spaceport America in New Mexico, so be sure to stay tuned for those.
No issues at Vandenberg. All elements of the system, Falcon 9, spacecraft. Now, LOX topping of the first and second stages is continuing. One of the events inside of T-minus 10 minutes is we'll open up the pre-valves to the 9 Merlin 1D engines on the first stage. At this point, we'll begin chilling in the turbopumps on the engine, getting them ready for the liftoff requirements at T0. At that point, you'll see on the webcast the gaseous oxygen, white clouds coming out from underneath the base of the first stage. That'll show that the valves are open. We've begun chilling in the engines. We're working, as I said, no issues on CASSIOPE spacecraft right now. They'll do a final poll at T-minus 13 minutes, verify that they're ready and good to go for launch. We're also working no issues at the range. Weather continues to look good. We're currently looking at the last balloon. We released a balloon about 100 minutes before launch. That gave us good conditions for the T0 coming up in just over 20 minutes. We're now releasing more balloons as we go through the morning, just in case we need them for later launch opportunities. Finally, the Falcon 9 team here at SpaceX has put in a tremendous amount of work over the years getting ready for today's launch. Now, we've enjoyed successes with our previous Falcon 9 flights, but that's no guarantee of future success. So with that, we're focused on the launch that's in front of us. We recognize, though, that even with all the steps, all the work that we've put in, the testing, the verifications, the reviews, that this doesn't demonstrate that we are going to succeed, because space is difficult. This is a Falcon 9 demonstration flight today. But we put all our effort in, we've done our reviews, and the team is ready to launch Falcon 9 to space today.
So what you've been seeing in the webcast is all of our ground cameras. Now what we're going to do right when we get it near liftoff is switch you over to our vehicle cameras. We have cameras on board the rocket, both looking up and down, and we'll be sending those back through our antennas so you can see those live. It's a much better view than trying to watch the rocket from the ground. So the camera on the second stage is about 20 stories up looking down. And as we lift off, you'll be able to see the California coastline disappear below us. And as we get into space, we'll start aiming the camera up towards space.
Now, another comment about our video signal that Jessica was talking about. The onboard cameras will switch views as we go through flight. Now, we may lose video for a few seconds as the vehicle is making the switch between one camera view and the other. Now, in this case, that should be normal, but we'll try to get the views back to you on the webcast as quickly as we can. Now, the status you've just heard, let me talk about one other thing that you'll see coming up. Currently, the Falcon 9 is out on the pad. The strung back or transporter erector is up around the vehicle right now. This will stay in position up until just inside of T-minus 6 minutes. At that point, you'll hear in the countdown, see on the webcast, the clamp around the second stage will open up. The transporter erector will then begin to recline away from the vehicle to get into position to support launch at T-minus 0. A little something different than previous flights. So with that, let's take a look at Kiko downstairs.
Jessica are actually webcasting you from the mezzanine level here in Hawthorne. I'm down on the ground floor right outside Mission Control. Now, as you can see and maybe kind of feel from your view at home here, you can see that the team is starting to gather and get excited and get ready to watch this launch. Now, we come out and watch the launch together because all of us are completely and 100% invested in getting our customer to orbit successfully. And now, while there's people here at Hawthorne, we also have our employees at our Texas test facility, at the Cape Canaveral launch site in DC, and also some employees from Hawthorne that have driven up to Vandenberg to actually go watch the launch. So like I said, everybody is completely vested in making sure we get our customer in orbit successfully. Now behind John and Jessica, you may have noticed the Dragon spacecraft. We're not flying Dragon today, but it is kind of a reminder of the things we've done and where we're headed in the future. We've had 3 successful Dragon flights to the ISS recently to deliver commercial cargo under NASA's commercial resupply contract. And then the spacecraft you actually saw behind John and Jessica, that was the first Dragon we flew. It was launched in December 2010. It did 2 orbits around the Earth and then splashed down in the Pacific Ocean. And at that time, we became the first commercial entity to actually launch and successfully recover a spacecraft. Now, we're kind of getting closer to launch, so I want to remind you to make sure to check the website or the Twitter or the SpaceX Facebook feed for any updates that you may want to see during or after the launch. And also, if you're interested in maybe getting some merchandise like a t-shirt or a hat that's got the SpaceX gear on it, feel free to check out the SpaceX store also. Now, because we're getting really, really close to launch, and I'm getting excited about watching this thing, I think I'm going to go ahead and put the microphone down and get ready to watch the launch with the rest of the team.
Yes, thanks, Kiko. And just above you here in the mezzanine, we can also feel that buzz, the energy, as the crowd continues to watch our Mission Control Center team supporting the folks at Vandenberg counting down the Falcon 9 for launch. Now, the next big event is the terminal countdown poll coming up at T-minus 13 minutes. Now, up till now, for the last hour or so, it's been very quiet for the Falcon 9. As I said, mostly we've just been topping off helium. We haven't been doing a lot of active work on the vehicle. This gives us an opportunity or a buffer in the countdown, so if we'd had to work other issues, that we had some time. Now, once we get into T-minus 13 minutes, then activities will start clocking down as the computers take over control and take the vehicle through the last 10 minutes of the countdown. So what we're going to hear at T-minus 13 minutes is the SpaceX launch conductor. They'll poll 20 individuals to verify readiness to enter the terminal count. The vehicle controller, the ground controller, the chief engineer, the Air Force folks who are supporting the launch. Now, for a lot of folks, that sounds fairly dry, Jessica, where we're just listening to 20 people all give a go. For me, that's where I grew up on in the space age, is that countdown poll. So I always get a bit of a thrill listening to it as we get those goes for launch. Now, once we finish that, we'll hear the launch conductor giving instructions to the SpaceX team on what to do in case they find a reason to hold the count as we get into the terminal countdown sequence. So if that were to happen, typically we'll recycle to T-minus 13 minutes. We'll be listening in, letting you hear as we go through that recycle procedure so that we can pick up on making sure the team is safing the vehicle, getting it ready possibly for another launch attempt, and going to T-minus 13 minutes. The other things that'll happen after the instructions will be the actual terminal count starting at T-minus 10 minutes. I talked to you about we'll open pre-valves and begin chilling in the turbo pumps on the first stage engines. There'll be at about 7.5 minutes a final go poll involving just a few limited individuals, including the Air Force. We'll switch the vehicle from external power to the internal batteries on the first and second stage. We'll retract the strongback that I talked about. Then we'll make sure that the flight termination system armed and the ranges go down, culminating with Falcon 9 with CASSIOPE heads into outer space. So with that, we're going to wind down for a minute, let everybody hear the countdown net over the webcast as we go through the poll, and then we'll come back, hopefully at the end, and wrap up. If there is a problem that recycles, then we'll come back and talk about it a little bit later on. So with that, 13 minutes to go, let's listen in.
All right, attention on the countdown net in section 10.54. Stations report logged in and ready for launch. VC.
VC's go.
GC.
GC's go.
GS.
GS's go.
Prop.
Props go.
ABI.
ABI's go.
Flight software.
Flight software's go.
GNC.
GNC's go.
Ground.
Ground is go.
RC.
RC is go.
FRC.
FRC's go.
FTS.
FTS go.
OSM.
OSM go.
FISBO.
FISBO go.
ROC.
ROC go.
Mission Manager.
MM go.
CE.
CE's go.
LD.
LD go.
SE.
SE go.
OD.
OD go.
LDA.
LDA go.
LD report go to initiate terminal count.
You have go to initiate terminal count. And LC, this is VC on countdown 1. I'll take a complete on section 10.54.
Yes, start terminal count.
And LC per 10.55, ready to start terminal count.
Yes. All right, attention on the countdown net at step 55.1. If a hold is called from this point forward, the terminal count auto sequence will be aborted. Indicate an abort or hold condition by saying hold, hold, hold on the primary countdown net. In the event of a hold, the VC will immediately abort the auto sequence. The VC shall not abort the auto sequence after T-minus 10 seconds. If a hold is called, all operators proceed to the terminal count abort steps in section 10.56. By to pick up the count, T-minus 10 minutes and counting on my mark. Mark. VC, announce the terminal count auto sequence has started.
Auto sequence has started.
RCO, confirm the clock is counting.
RCO, clock is counting.
GC, stand by on FireX.
Standing by.
RC, start the range video recorders.
Range recorders started.
Prop, confirm stage 1 when pumps are fully chilled.
Engines are chilling in. Engine fuel trim valves and bipropellant trim valves are cycling. Ready to close out attitude control system filling, closing out.
All stations,
SC go.
OD,
OD go.
LD.
LD is go for launch.
Copy. LDA, verify clear to launch.
LDA clear to launch.
Copy.
Vehicle heaters closing out.
AVI, please report vehicle transition to internal power.
Setting auxiliary supplies. Internal power.
Ground TBC system is being configured.
Pressurization for strongback retract. And GC report start and completion
All
of
tanks
strongback
pressurizing.
retract.
Strongback lower has started. Cradles are opening. West cradle full open. Second stage TBC is cycling.
Copy, taking step complete at 55.13.
Strongback motion has started. $85. $80. Strongback is retracted.
FTS, confirm FTS is on internal power.
FTS is on internal power.
FISBO, confirm FTS is on internal power.
FISBO confirms FTS on internal power.
FTS, confirm that the FTS system is armed.
FTS is armed. LOX load is closed out. Strongback has been pinned. Tanks pressurizing for flight press using the pre-press system. Flight.
Rock, confirm that the range is green.
Rock, range green. Vehicles in self-align.
Report that vehicle gas
Supply is activated.
state changes.
Roger. Vehicles in auto idle. Vehicles transition from ground auto sequence to flight auto sequence. Second stage tank pressure coming up.
T-minus 30 seconds.
All tanks at pressure.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Liftoff. Prop AVI GS 10.59. GC move to section 10.58.
GC is in 10.58. First stage propellant utilization active.
Send Nicholas Island has data.
Awesome copies. The vehicle remains in a nominal trajectory. Altitude is 5.8 kilometers, velocity of 467 meters per second, downrange distance of 600 meters. The vehicle is supersonic.
Good telemetry, good power health.
The vehicle is passing through maximum aerodynamic pressure. Second stage engine chill has... The vehicle remains in a velocity of 1.1 kilometers per second, downrange distance of... Nominal trajectory, altitude of 61 kilometers, approaching MECO 1 of 1.8 kilometers per second, downrange distance of 45 kilometers.
Confirmed.
And that ignition confirmed. Stage 2 propellant utilization active.
Fairing separation confirmed. Telemetry still nominal.
Roll. Trajectory, altimeters, velocity of 2.9 kilometers per second, and a downrange distance of 383. Propulsion looking good.
Nominal.
The vehicle remains in a nominal trajectory, 275 kilometers, velocity 165 kilometers.
Cook is still up.
Ten kilometers, velocity.
First stage is burning, or relighting at this time.
Stage 2 is transition to terminal guidance. FTS is saved. Approaching SECO 1. And next.
Vandenberg Air Force Base, loss of signal on second stage, expected loss of signal. But that was a little bit better than we predicted.
What a ride. Yeah, you can hear the cheering behind us as everybody was following along the Falcon 9 team as we rode to space. It was an amazing flight. So far, I mean, tons of data coming back. It looks like it was a picture-perfect flight. Everything was looking good, right down the middle of the track. Looks like orbit's good. So we'll be waiting to hear as we go on through the morning. But I think right now, that brings us to the end of the scripted events for the morning. So I think right now, let's throw it to Kiko, who's downstairs with the crowd, and then come back to us, and we'll be signing off.
Yeah.
Pretty awesome launch. Everybody down here, super. I think we'll definitely want to get right back to work and get ready for the next one. That's what we do here.
Thank you, Kiko. Well, from the SpaceX team, just to wrap it up.
Just want to thank all of you for demonstration launch, and it went. We're glad you all tuned in. So, grasshopper stuff, and we have a lot more Falcon 9 launches coming. Thank you.
Yeah, I think right now the plan is there'll probably be some type of media conference later on this afternoon. Tie into our website, see what's happening, as well as we'll give updates as we go along in the mission. But for that, also want to send thanks for not only the people that support us, but MDA Corporation, who rode with us on the Falcon 9, as well as our other SmallSat partners. It's been a great day here in Hawthorne, a great day at Vandenberg, and all over the SpaceX crews, and McGregor participating, working along here. So what we'll do is close the webcast with a fact. We've got another launch out of the Cape coming up in just several weeks, where we're going to get to live this all over again. So with that, a goodbye from Hawthorne, California at the SpaceX factory.